Hey guys, Dean Chase here with another geometry lesson for you. I hope you guys are all doing good. Let's go ahead and get this thing started with a word of prayer. Dear Father, I want to thank you for this day, goodness, Lord. I want to thank you for all that you do. I pray that you'll help us have a good day. Bless my students. Bless my viewers. We love you, Lord, and thank you for all you do. In Jesus' name I pray, amen. Alright guys, today we're going to be covering how to use midpoints and the distance formula. This is lesson 1.3, page 15, if you're working on the same book as me. Here we go. So midpoints and bisectors. The midpoint of a segment is a point that divides the segments into two congruent segments. A segment bisector is a point, ray, line segment, or plane that intersects the segment at its midpoint. A midpoint or segment bisector bisects a segment. So here you go. This is a midpoint on line AB. M is the midpoint. So AM and MB are the exact same length, okay? They're congruent. Next we have a line bisecting line segment AB. So AM is the same as MB again, okay? Hope that makes sense. Let's just get into some examples and have some fun, you know what I'm saying? Here we go. The figure shows a gate with diagonal braces, MO, which diagonal braces. MO bisects NP at Q. So MO bisects PN at Q, okay? Which means that it cuts PN or MP perfectly in half. So PQ and QN are the same length. So to find out what the whole length of this would be, if we know PQ is 22.6, all we have to do is take 22.6 and multiply that by 2. Which is going to give us 45.2. PN equals 45.2. Not too bad. Just important to remember, if something is bisected, it's cut perfectly in half. Okay? Let's keep going. Example 2. Point S is the midpoint of RT. So this is the middle. So what that means is that RS equals ST. And that makes it really easy to solve for x now, because we know that 5x minus 2 is going to equal 3x minus 8. So 5x minus 2 equals 3x plus 8. Now we just have to do the simple algebra to work through this. You all know what you're doing, but I'm going to work through it anyways. We're going to add 2 to each side. These 2's are going to cancel out. We're going to be left with 5x equals 3x plus 10. Subtract 3x from each side. Our 3x's cancel out, and we're left with 2x equals 10. And last, divide by 2. X equals 5. Not too hard, but that's not the question. The question is, find ST. So what we have to do is take our x value and plug it back into our formula for ST. So 3 times 5 plus 8 equals ST. Okay? So 15 plus 8 equals ST. 23 equals ST. Not hard math. Hope that made sense. That's going to be using bisectors, because we know if something is bisected, it cuts it perfectly in half. That's what I'm trying to get you to remember. That's the important thing. If it is bisected, it's cut perfectly in half. Let's carry on. Coordinate plane. So here we're going to learn how to find the midpoint in a coordinate plane. You can use the coordinates of the endpoints of a segment to find the coordinates of the midpoint. So if I were taking notes right now, let's just do this. I would write the midpoint formula, and then I would write this down here. All the rest of this is just jibber jabber, but I'm going to read it to you anyways because I like jibber jabber. The coordinates of the midpoints of a segment are the averages of the x-coordinates and the y-coordinates of the endpoints. If A and B are points in a coordinate plane, then the midpoint M of AB has the coordinates with this formula. So all you're doing is taking the average of the x values separate from the y values and finding out what the average of the x's and y's are. And that's going to be your midpoint. And you're going to do that with this formula. And guess what? We're going to do examples of it and have all sorts of fun with it. So example 3. The endpoints of GH are G, which is 7 minus 2, and H, which is negative 5 minus 6. And they want us to find the coordinates of the midpoint. Well, we're going to use our handy dandy midpoint formula. So I'm going to go ahead and just label this x1, x2, y1, y2. And I guess I'll do a little side lib, a blurb on this. It doesn't matter what you call x1 or x2. The only thing that matters is whatever you call something like x1 in the coordinate pair has to be 1 also. So if this is x1, this has to be y1. If this was x2, this would be y2. Okay? All that matters is that you keep the coordinate pairs having the same sub number. Let's just go ahead and work this out. So 7 minus 5 over 2. Oh, 7 minus 5, sorry, over 2, comma, minus 2, oh, not minus, sorry, this is 7 plus minus 5. You gotta watch me on that stuff, okay? Minus 2 plus minus 6 over 2, okay? And that's gonna equal our midpoint P. So 7 plus minus 5 is going to give us a positive 2 over 2. And negative 2 plus negative 6, you owe somebody $2 and you spend 6 more, you then owe them 8 over 2. And it's all equal to P. So 1 comma minus 4 equals our midpoint P. Not too shabby, not too hard. Just some pretty simple math, so let's just go ahead and keep rolling along. Example 3, continued, or part B, whatever you want to call it. The midpoint of AB is M, which is 5, 8. One endpoint is A, which is 2 minus 3. They want us to find the coordinates of the endpoint B. So to do that, we have to find, man, I got a cricket in here and it's about to drive me nuts. Anyways, we know the midpoint and we know one endpoint. So what we're going to do is we're going to just fill in this as x1 and y1, okay? And this is the midpoint. So x1 is 2 plus, we don't know the other x, over 2, comma, minus 3 plus, we don't know the other y, over 2. And that's equal to 5, 8. The way I like to go about solving this is I like to split it into 2 separate equations where we use our x values in one equation and our y values in the other equation, and then we just form a coordinate pair again at the very end. So, like I said, we're going to take our x values and make one equation, and our y values and make another equation. So here we go. 2 plus x over 2 equals 5. Okay? And then our y equations are going to be negative 3 plus y over 2 equals 8. Okay, let's just go ahead and solve for our x values. We're going to multiply this by 2, because if you have a number in the bottom of a fraction, you multiply to get rid of it. We're going to be left with 2 plus x equals 10, because 5 times 2 equals 10. Subtract 2 from each side, and these 2's cancel out, and we're left with x equals 8. Solve for y, do the same thing, multiply each side by 2. Negative 3 Our 2's cancel out, by the way. Negative 3 plus y equals 16. We're going to add 3 to each side. Y equals 19. Okay? So, B equals, or we don't even need to say equals. That's B is 8, 19. And that's how you find an endpoint if you're given one endpoint and the midpoint. So these were two really good examples to have for doing your homework. Last thing we're going to learn about today is the distance formula. The distance formula is formed by computing the distance between 2 points in a coordinate plane. So once again, if I was taking notes, I would write the distance formula and I would write the actual formula. If A is x and y and B is x, y are points in a coordinate plane, then the distance between A and B is D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. That's how you're going to find the distance between any 2 points in a coordinate plane. And later on in this chapter, we're going to be learning about perimeter, and some of the questions will have to use the distance formula to add up the distance around the perimeter. So this one you're going to be using later on in this chapter, so make sure you pay attention here. Example 4. What is the approximate length of PQ with endpoints P, which are 2, 5, and Q, which is negative 4, 8? To do this, first thing we need to do is I'm just going to write down the distance formula, which equals D equals the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Okay? And I'm going to also label x sub 2, x sub 1, y sub 2, y sub 1. Okay? And we're just going to go ahead and plug these in our distance formula. So D equals the square root of 2 minus 4 squared plus 5 minus 8 squared. Okay, a quick side note. I know we love just punching full equations into our calculator, but we really have to be careful and make sure we use an appropriate amount of parentheses if we're doing that. So here we have a parenthesis, and then here we have another parenthesis containing our negative 4, and then we have to close off this whole equation with this last parenthesis to square it. It's just really important to have an appropriate number of parentheses, otherwise your calculator can actually get confused. If I'm doing a calculator with this type of equation, I like to do actually each step. So like if I did 2 minus 4, I like to type that into a calculator individually and then write it down again just like I solved this. So D equals the square root of 2 minus 4 is actually the same thing as 2 plus 4. So that's going to be 6 squared, okay, plus 5 minus 8 would be negative 3 squared, okay? D equals the square root of 36 plus negative 3 squared is 9. Anything squared should be a positive number here because negative times a negative times a negative is positive. A positive times a positive is positive. So, what gets you is if you don't put parentheses in your calculator and you just do negative 3 squared, your calculator actually only thinks it's squaring the 3, so it'll say negative 9. So we have to be careful when we're using our calculator. D equals the square root of 45. So D roughly equals, because they want approximate, if they say approximate, go ahead and put it in decimal form, equals roughly 6.71. That's today's whole lesson, guys. Not too bad, not too shabby. I hope you understood it. Thanks for following along. Please feel free to subscribe to my channel, like my videos, ask me questions in the comments. I'll try and do my best to answer them. If you're one of my students, ask me in class or hit me up on Jupiter or whatever. But that's it for today, guys. See ya!